So hello everyone. So today we'll be discussing about Dragon Hatchling. So it is a design framework which is designed by Pathway. So it is basically used for continuous narrative understanding over time, or we can say classification of text, or we can say it basically does it. Um, it analyzes, like if we have a novel and it analyzes the novel, it stores it, and based on the uh, training, it gives us consistency checks, casualty constraint, various constraint checks, like if novel or any sentence is consistent to the novel or contradictory to the novel. So it stores the tags, various tags, events, character activities, and other things for the reasoning purposes. And even main part of BDH is that it works in chunks. It divides the complete during training, divides the complete uh, training data set into chunks and then mimics it like how a human can edit this, or by using a human approach, it trains the model. So here we are working on the IIT KGP hackathon project, which which needed us to use BDH architecture to implement to solve a problem which was to train a model based on the various parameters which we had two novels and one trained data set and test data set. So we need to generate a model which checks for if the given context is contradictory to the novel or consistent to novel. And contradictory is represented by 0 and consistent is contradictory is represented by 1 and consistent is represented by 0. So BDH helps us because here we use only a natural language processing and not any external LLM model or anything. So let me just show you. So this is I have trained everything on my this virtual machine that I have from Azure. So let me just show you. So it's basically readme or can config info. This uh, these are our two models. This is regional.pt and business-based.pt. These both models are trained using different methods. Uh, so this was our train.bdh used for regional.pt and written.py for regional-based.pt. So these requirements and result is our last final after we do the testing. So we have data. So in So in data, we have two novels, tasks. So it has bigger names. So I sorted them for my purpose and test CSV and train CSV. So uh, these are various data. It had 81 rows of various book names, IDs, and other things. And this had 61 rows of book names, IDs, and context. And these two had 100K plus lines of knowledge. So basically, this was our data. Okay, just so let me show you our video. So this is our BDH. This is very simple from GitHub repository, and this you can just ignore this. So this is the basically our train.py and model.py from our basic BDH repository. Let me show you here. BDH. Let me just keep the screen from here. Okay, so it is not okay. Yes, 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 yes. Okay, so now we have people. So these are BDH per 10.5. And the model.py was ours. Now let's just go back to the let's go. So these are terminals, these are BDH and these are our these are basic ADS architecture. These some you can explore this file correctly that I used during the development of this process. So let me just go to my yes. So uh, this is a so this is just a temporary and store file. So let me tell you this info.py and there is a this too. So info.py was used to test the model, this model, test this model, and the info.py was used to test this model. So basically, this model was trained. How this model was trained was I had basically put two epochs using the train.py using BDH architecture and in the chunks of find 2048, two chunks of 2048, and trained for like uh, 6 to 10 hours, and we got the model of return.py with accuracy of 3.3% almost, and a very and a loss of almost 30 to 40%. It and this the model was trained using cache data. Like it is while to training of this model, I use a thing is called like caching. It used like cache every first cache the novels, both the novels. Then in caching is saved the model after every single epoch. This was the first model only saved the model after all the process is completed. But this one is for safer. If you want to retrain, you can retrain this model anytime. So till I trained this model two times. First was with 20 epochs, and the second one was 50 epochs, and gained the accuracy of almost 60, 60 to 80%, almost 75% approx. This was the accuracy. So various libraries that were involved in this. Let me show you. So these were the important libraries: Solve, Transfer, Pandas, Numbers, etc. It's mostly the libraries in what we show you. So these were important libraries we use. BDH models, reasoners, memory. So memory was for so we can save it and use. This was equal 50, which I just tell you, and this was the learning ratio. Chunk size was 5 and 2 for the uh, cache cache one, and we have used torch CUDA, so it uses the CPU and not different GPU. We use this is a virtual machine. So we have here load the data set from train.csv, and there we have count the number of consistent and contradict which was given in our training set, and these were memory module and resource module, which were from BDS only that we have imported from GitHub. So these are cache, and these are our two books. So these were to go, and these were the license that I given Castways and Monte, uh, Monte Cristo. So this to caching the model saves after every inference. So this was our model 50 box. So let me show you. Mm. Yes, mm. So this was a similar type of model, but it did not save this. These were our map. These were our country. threat and contradict. And this one 512 and 2 epochs. And this one was a learning issue. It was a bit low, but according to epochs, this was a high learning ratio. This was chunk text. Chunk split the words into size of 5 and in the size of 5 to using our same the device that you use was a CPU and the same additional module is memory module and the epoch in this the epochs were like we had to move so we done the epochs for 2 times to get the best one. But if you want to get the best of this, you need to we can have at least 5 to 6 epoch. So the curve, the model won't be underfit or overfit, but 2 to 5 is the best ratio for this type of training, like or based on your sequence. What type of speed you have. And let me just show you the reason. If no, then yes, I guess it does not have a reason. Let me just check for the reason if I have them. I guess I have. So let me just shift again. This university plan. So you can you can see this contradiction consistent content. These are our various IDs and the labels. So this is your final output. Mm, Thank you for watching. Bye.